We are going to talk today about solving radical equations. Let's start here. I've got the square root of the quantity 3x plus 4 is equal to 5. What is weird about this? The radical is weird. If we get that out of there, 3x plus 4 is a lot easier to solve for. So let's do just that. How can we get rid of a radical that tells us to take the square root of this quantity? Square it. Square both sides. Then you're left with the square root of 3x plus 4 times the square root of the quantity 3x plus 4 is equal to 5 squared. Or keep it up, 5 times 5. Sure, why not? If you are multiplying a square root by itself, in other words, if you are squaring a square root, you are effectively undoing the square root. So this together will combine to be 3x plus 4 when we multiply them. That is the product of two square roots. It's whatever is inside the radical. Simplify on this side. 5 times 5 is 25. I don't know about you, but I think this looks a lot easier to handle from here. Quantity 3x plus 4 equals 25. What should I do next? Subtract 4. 3x equals 21. What to do next? Divide by 3. Isolate that x. X equals 7. Now, you're not quite done yet. In this case, everything is going to work out hunky-dory. We're all happy, sunshine, lollipops, and rainbows. However, it will not always be the case. Sometimes you will get a solution which does not work. We'll get to that in one moment. Let's do the check, though, so we get into the process. Take your solution, or solutions, you may have multiple, and plug it back in, make sure it works. So the square root of the quantity 3 times 7 plus 4, we said, is equal to 25. I'm just substituting in for where the x was. Simplify. 3 times 7 is 21. Plus 4. Simplify again. 21 plus 4 is 25. Whoop, 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 whoop. I'm in there. I was so excited. I should have gone back to the original. Okay? My apologies. 3 times the 3 times 7 plus 4, that quantity, the square root of it, should be equal to 5. Simplify, still equal to 5. The square root of 25 is equal to 5. Is 5 equal to 5? Yes, it is. There's nothing weird going on. What could be weird is this. Can you have the square root of a negative number, like square root of negative 4? If you are dealing with real numbers, which for right now we are, no, you cannot do that. You cannot multiply two real numbers by each other. You cannot square a real number to get a negative. It does not work. Similarly, you cannot take, you can't do that. It just doesn't work. Okay? Doesn't work. That was my point. All right. So let's look at a case. The square root of the quantity 73 minus n is equal to n minus 1. Now, slightly more complex, not terribly. We will have to dust off the quadratic formula, but that is old news by now. Let's square both sides. This becomes 73 minus n is equal to, go back, it's a binomial, square it. We get n squared minus 2n plus 1. Let's get all of this over here so that we can use the quadratic formula, or in this case, it actually factors out quite nicely. So I've got to add n to both sides. That leaves me with 73 equals n squared minus n plus 1. Get this 73 out of here. Subtract 73. Remember that in order to use the quadratic formula, you must have 0 on one side of your equation. N squared minus n minus 72 is equal to 0. So remember, your coefficient that's in front of here would be an A, coefficient in front of here would be a B, and this whole thing is your C when we talk about the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. You've seen this before. That's an old friend. Plug in, so I've got negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 72. All over 2 times 1. This becomes 1 plus or minus the square root of 1. I've got a negative 4 times negative 72 times 1. The 1's really not going to change anything. Negative 4 times negative 72 will make this plus 288 over 2. Simplify again. 1 plus or minus the square root of 289 over 2. 289, I'm like, that's a weird one. I haven't seen that square a lot. Make sure you've got your calculator. So we take the square root of 289, gives us 17. 1 plus or minus 17 over 2. This is what our x is equal to. So you've got two cases now. Let me make a little bit of room over here. You can still see, okay. So I'm going to have x equal to 1 plus 17 over 2, which is equal to 18 over 2, which is equal to 9. I'm also going to have another case where 1 minus 17 over 2 is x. That's negative 16 over 2 equal to negative 8. So right now I've got two possible solutions, a set of negative 8 and 9. Okay? Sounds great so far. But as I said, you have to check and see where you are plugging into and what works, what doesn't work. All right. So if I plug in, let's go back to the original equation. Let's test 9 first. Square root of 73 minus 9, equals n, 9 minus 1. 73 minus 9 is 64, so the square root of 64 is equal to 9 minus 1, which square root of 64 is 8. 9 minus 1 is 8. Aha! This guy works. We're almost there. We also need to check out negative 8. We go back, we repeat the process. You need to check. You don't check, you can do weird stuff. Square root of 73 minus negative 8 equals negative 8 minus 1. I've got square root of 85 is equal to negative 9. Not 85, I'm sorry, 81. Literally. Now we don't want that to be there. The square root of 81 we would like to be positive 9. Since it's giving us a negative, we have to rule this out. This negative 8 is what we call an extraneous root. It does not work. You've got a result of a negative over here. We want this to be a nice positive number, because when we graph a radical function, on the graph it's going to be something, generally something nice like that, just one side. We're not going to get into this area down here. That is a no one's land. All right, and if we really think about it, this n minus 1 is actually another line that comes through, and the two intersect at that point right there, where we would have our first solution, where x is equal to 9, and then when we plugged in, 9 minus 1 is 8, just as when we had 73, the square root of 73 minus 9, the square root of 64 equal to 8 as well. So you can also find that graphically, to double check, in your calculators, you can put this down is y1. I'm going to erase all this stuff here so that you do not get overloaded. y1 is equal to the square root of the quantity 73 minus n. And then your y2 would be equal to n minus 1. You can find where they intersect as well. There are many ways to find a solution in mathematics. Certainly this algebraic way is very clear and precise, but the graphing way will help you solve that as well. A lot of stuff here. Bring in your questions. Have a great day.